GIS technology. So it's used in a vast domain. Like you say any application where GIS, like GIS can be used. Like it can be urban planning. Like if you want to create a certain planned city or something like that, that GIS is used. So there's a vast application of GIS in urban planning. So next application is mining. Let's say you want to uh, uh, find the ores or mine, something like that. That GIS has been used, like finding the exact location, finding the more detail about that location. So that the GIS is used. So GIS is like doing analysis on the data, on the spatial data. Yeah, someone wants to say something. Okay. Okay, next image. So I think this image we all are aware, right? Right? Can anyone answer what is this? Like which map is this? It's there in the screen only. Uh, can someone speak up? This is the COVID outbreak, right? So it's showing where the count of the uh, COVID patients, right, in the world. So this is GIS, like mapping. So all the mapping and all the applications comes under GIS. Okay. So what we can do with GIS? So we can map the area. We can do detailed analysis of a particular location or area. Uh, we can have various data layers. Like we can have various data of a particular application. Let's say we want to do application on a precision agriculture. So we can have various layers. Like we can have the land layer. We can see the other buildings, the nearby location, nearby village. So all that data which is we are collecting is a spatial, which is geographically correlated, like geographically related. So all the data is been geographically related. So that's spatial data. So we can use it in various software like navigation, routing for our various applications. We can do various like in various careers, like in the UI you have various you want to see various see the analysis and uh, the UI of the various application. So there GIS has been used in mobile phone apps like Pokemon Go and various softwares uses GIS technology. Okay, so that was just the overview of what GIS is. Like next is spatial data. So what actually is spatial data? So spatial data is any type of data that is directly or indirectly a reference to a specific geographic area or location.
click பண்ணேன்.
Uh, can someone unmute, like mute yourself, please? You're unmute. Can you? Yeah. So spatial data is any type of data that is directly or indirectly reference to a specific geographic location or area. So 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 here in this image you see various layers, right? So this is a real world. So this is the real actual world on the and then we can have various layers of that. So one could be the elevation layer, like the what is the elevation of the particular layer. Then we can have the image layer, like what's the, like this image can be a satellite image or a drone image. Then we can have the image layer. Then we can have, so in image layer you can classify into various sub layers. Like we can classify into land use layers. So then you can classify as streets, wherever the streets are, wherever the water bodies are. So you can classify it into various layers, and you can use it for spatial analysis. So that is this is all about spatial data. So in GIS there are basically two data models, raster and vector. So these raster and vector models are basically used in GIS to do all the analysis and the application. So data model is just a logical representation or a set of guidelines for the representation of logical organization of the data. So in GIS we have two types of data, raster and vector. So what is raster? So raster data model presents is like an image. It's an image. Raster model is an image. So it presents information through a grid of cells. So this grid of cells are called. Can anyone tell uh, what we call this grid of cells in image? Pixels, right? We call this picture element pixels. So this is a pixel. So in raster, we denote all the like data in the form of pixels in a grid of cells. Uh, so all this grid have, so particular grid have value in each cell, like whatever value we can have grayscale value or binary, we can have values in the grids. So that's the raster data. So it's used in digital imagery from satellite data, from lidar, and then radar imaging. So all the imaging basically uses this raster data. Next, we have vector data. So in GIS we have vectors. So uh, can anyone can have you guys explored like zooming the map, Google Map? So what's the difference between zooming the Google Map and Google satellite image? Can someone tell if you have explored this before? Please speak up, guys. Like a response here. Yeah, someone have answered. The area looks more and more precise. In which Google Map or a satellite image? Goshika Saravana. Pick up. Okay, the difference is that if you zoom a Google Map, you can zoom it as much as you can. Like there is no limitation for zooming it, right, in Google Map. But if you zoom a satellite image, so after a certain level, you won't be able to zoom it. So you will see a blur kind of thing. Like you won't able to see the data properly. So so in Google Map, it's a vector data. So vector data is basically a mathematical functions. So it uses mathematical functions to display the data. While as in raster, you use pixels, the image pixels to display the data. So pixels after a certain level, you can't zoom it. Like you are not able to zoom that data after particular extent. But in vector data, you can zoom it as at any extent. Like you can see all the details in the map. That's why the Google Map you see, you can zoom it as much as possible. And yeah, so vector data can be represented by point, lines, and areas. So this is the mathematical functions. So it uses points, lines, and areas. So it can be also called as polygons. So areas are polygons. So all these are represented using coordinates. So this all this data are represented using coordinates. So points is defined by the xy coordinates, the latitude and longitude. So I will be covering what latitude and longitude is. The lines is defined by the various points. Like you can have various points and define a line, right? So it can be a you can have various lines. So these are polylines. So you can have various lines, small lines, which can form an arc or a curve. Very small lines. So you can also have polygons. So polygons are lines that are interconnected. Like if the start and the end point of a line is connected, of the various lines are connected, you will get a polygon. So all this data is a vector data. It's a mathematical functions. Whereas in raster data, you have pixels. So in this image, you see these are pixels, grade wise data. So you cannot zoom this data after a certain extent, whereas you can zoom this at any extent. Yeah, is there any question? Okay. Please mute yourself even if you are not speaking. Next is concept of this layered representation of spatial data. So in spatial data, we can have various layers. We can have various layers of raster and vector. So let's say we want to do an application on a let's say precision agriculture. So in agriculture, what is important for us is the land elevation, right? Where the land is located. Then we want to know what are the water bodies. So land elevation could be the one layer. Then water bodies can be the one layer. Then the soil layer, like what soil is present, that could be the one layer. Then how the land is being divided, like where the village is, like where the locality people are staying, where the agriculture farms are, that could be the other layer. And such wise we can have various layers. We can use these layers to do analysis, like we can overlay these layers one upon the other and do various analysis, like uh, how the farming process could be eased and the cultivation could be increased. Yeah, the other could be a single map layer. You can also have a single map
அந்த
layer
photo
and do
நம்ம
analysis
போட்டு
on that. Guys, please mute yourself if you're not speaking. Yeah. So that those are the two operations that you can do on the spatial data. Next is the geographic coordinate system. So what is the shape of the Earth? So we are studying this from the school time, right? So this is the geography lesson we studied in the schools, right? Right from standard first. So what's the shape of the Earth, guys? Can anyone speak up? Is there any comment? Spherical, yeah. Someone said geoid, yeah, geoid, good. So Akash, can you tell what is the geoid shape? Spherical, we all know, right? Geoid. Okay. Uh, the shape of the Earth is so. What is spherical? Spherical is just a sphere-like shape. What is spheroid? So, can anyone tell what is spheroid? It is a oval-like shape, like the oval shape. And what is geoid? So, geoid is basically the spheroid, oval-like shape with irregularities on the surface. As Earth, on the Earth, we have various lands and water bodies, right? So, there are irregularities on the surface of the Earth. So, that shape is called as geoid. So, the shape of the Earth is geoid. So location system. So I think we all are aware what latitude and longitude is, right? So so latitude and longitude are basically used to uh, to have a reference system for the location. So latitude are the so what is latitude? Latitude is the lines that you cut parallel to the North Pole and the South Pole. So I guess you know the where North Pole and South Pole is, right? Top is the North Pole and bottom is the South Pole. So if we cut lines parallel, like if we cut the Earth, let's imagine the Earth is spherical. It's not the spherical, but let's say it's spherical. And if we cut an imaginary circle on the surface, so that is parallel to the North Pole and South Pole. So that is latitude. So they are also called as parallels because they are parallel. So these are latitudes, and the central line that cuts the surface of the Earth is equator. And longitudes are the vertical lines that starts from the North Pole and ends at the South Pole. So imagine you cut a circle passing to the North Pole and South Pole. So that is the meridian or the longitude. It's also called as meridian. And the central line that passes to the North Pole and the South Pole is called as a prime meridian. So here it's called as equator, which passes to the center of the latitudes, and here the central circle, that line that passes through the uh, meridians, is called as a prime meridian. And combining this network is called as graticular network. So like latitudes and longitudes together are called as a graticular network. So all the GPS location that we see, like that we use, is based on the latitude and longitude of the Earth's surface. So this is like a reference for having the exact location, geolocation on the surface. Okay. So parallels are equally spaced between equator and the poles. So as you can see, this parallels, these latitudes, they are equally spaced uh, between the equator and the pole. So in the equator and here is the pole. So they are equally spaced. And any two parallels are always at the same distance apart. So if you see here, all these parallels are equidistant from each other. Like over the surface. Like here, so you can see these all parallels are this parallel is a equidistance to the equator, or here this parallel is equidistance to this parallel. Meridians are spaced farthest apart at the equator and converge to a single point at the poles. So here you can see meridians get uh, coverage at the poles, and it gets farther apart uh, in between. So yeah, parallels and meridians cross one another at right angles. So here you can see the parallels and meridians, they cross each other at right angle. Okay. So next is map projection system. So uh, Earth is a, let's imagine it's a spherical like shape. Uh, so we want to have the data on a particular paper, right? So we want to map that spherical data on a paper. So it's not possible to directly have all the data as it is on a paper, right? Like let's say you have a sphere and you want to map the area of that sphere on a particular on a plain paper, let's say a paper. So it won't be able to have all the data properly on that paper. So there are certain projection systems uh, decided, like done by the various geographical scientists. So there are various projection systems, like there are conical systems, there are cylindrical and azimuthal. So all these projection systems have various applications. So this projection system tries to project the data of a earth on a plain paper. So certain projection systems are used for certain applications, like conical projection system is used for east-west land areas, cylindrical are used for north-south land areas, azimuthal are used for global views. So this projection systems may not be able to get you the accurate data of the Earth's surface, right? Like the Earth is a sphere and we are projecting that data on a paper, so that data may not be the exact data. So because it's a projected data, right? Yeah. Any questions till here? Okay. Go. Imagine, yeah. Okay, till now there is no question. Yeah. Next is georeferencing. So georeferencing is the method of assigning the real world coordinates to each pixel of raster data. So in the satellite image, so whatever satellite image you see, so that image has a georeference data. So all the pixels are having a geolocation, like the every pixel position has a latitude and longitude value. So whenever you import any satellite image, you will see that it is geolocated. So georeferencing is a method of assigning real world coordinates. So real world coordinates are latitude and longitude to each pixel of the raster data. So let's say you want to survey via drone. So drone has a RGB camera, say, but it doesn't have a latitude and longitude of every pixel. So drone has a GPS, right? But the image that is captured, it doesn't have that. Every pixel doesn't have its latitude and longitude. And let's say you want to map this drone image. So this is a drone image, right? So you want to map that drone image over the satellite image. So here is a satellite image at the bottom, and you want to overlay this drone image over that satellite image. So for that, we need to georeference this satellite, this drone image. Sorry, this is a drone image. So we want to georeference this drone image first, so that it gets overlaid properly on the satellite image. So here you can see, so at the bottom it's a satellite image, over it you are placing a drone image, and we have georeferenced it such that it is aligning, like you can see here, it's aligned with the uh, background. So that is georeferencing. So these are the basic concepts that are used in GIS. So there are various tools and softwares for GIS. Like QGIS is the most popular software. It's open source software to do all the analysis, and you can do almost everything using QGIS. And next is the ArcGIS. So it's a licensed version of QGIS. Like this is a proprietary software. So it has various features. Like as it is a licensed version, it has a little more features than QGIS, but this is mostly used for industrial purpose. You can also use it if you have license in your colleges, but QGIS does all the work that ArcGIS can do. Except there are a few things that ArcGIS has, as it's a proprietary software. And then we have OpenStreetMap. So OpenStreetMap is a open source map. So in Google Map, you whatever map you see in the, that's not open source. It's a proprietary map by Google. But in OpenStreetMap, it's a open source map, anyone can use, and you can also edit this map as per your need. Like you can edit the particular area or the grid of the map. So it's open source map. And then we have a Leaflet. So Leaflet is a JavaScript library for using OpenStreetMap. So if you're planning to have some web application like GIS based web application, WebGIS, which is also called as WebGIS, then you can use Leaflet like JavaScript library for accessing OpenStreetMap. Then we have OS GeoLive. So this is a OS operating system by OSGeo, so which has all the software like QGIS, OpenStreetMap, Leaflet, OSGIS, etc. So it has various open source softwares for doing the GIS analysis. And then we have PostGIS. So I hope you are aware of PostgreSQL, right? Which is an open source database. So PostGIS is a plugin for PostgreSQL. So PostGIS, so it's a spatial database. So there is a difference between normal database and the spatial database. In spatial database, we can also store spatial data. So we have described the vectors, rasters, etc. Right? So all those vector data has a coordinates and geometrical locations, right? So we can store that vector data inside this PostGIS. So that's a specialty of PostGIS, spatial database. So you can store all the spatial database using PostGIS. Yeah. So these are the basic softwares. There are also various other softwares which you can use. So let's have a quick hands-on on the QGIS. So before that, if you have any questions, please free to ask. So yeah, that was the basic overview of the GIS tools and softwares. Any questions? Okay, I hope you all have filled the Google form that I've shared before. Okay, I think there is no questions. Then I will go further. Like, just I have one question for you then. So, what is the application of GIS apart from the what is mentioned in the slides? Any application that you can use? Can someone speak up? Yeah. Sorry. Okay. Someone wants the Google form link. I will share it. Uh, Please respond, guys. Like, I feel there is no response here. Okay, just I'm waiting for a few minutes to all to fill the form. After that, we will be having a small hands-on session on QGIS. Just write on chats if you are not feeling comfortable to speak. Okay, yeah. Someone has answered. In health sector, telecommunication industry, yes, yes. In health sector, you can use. In telecommunication industry, you can use. What are the other fields where GIS could be used? So spatial data is used everywhere, right? So think of some spatial application which relates to the geographic coordinates. Yeah, tracking. Yeah, tracking the location. The GIS could be used. Any other application? Yeah, animal and vehicle tracking, surveying. Yeah, border identification. Yes, extraterrestrial application. Yes, exploration. Yes. Okay. Uh, yeah, cool. So let's start with the hands-on session now. So I will be sharing my screen. So before that, I need to uh, collect the data. So I hope almost all have filled the form. So okay, yeah, monitoring and managing vehicles. Yeah, there are various applications. Wherever the spatial data is required, GIS could be used. GIS technology could be used. The most important is the mapping. Like whatever maps you see, it's GIS. Like let's say you want to see the rainfall, where rainfall occurs more, where it occurs less. So all that is GIS. So all types of map you design is a GIS. It uses GIS technology. Okay, so start with QGIS. So QGIS is an open source software, as I mentioned. It's taking time to load. Yeah. So it's open source software. You can install it in any OS. Like it supports all operating systems, Linux, Windows, and Mac. So you can install this and play around this software. It's very easy to play around. Like okay, are you able to see my screen? The QGIS window.
Yes, sir, it's visible.
Yeah. So this is the QGIS window. Let's create a new project. New. Yeah. So here you can see various toolbars. So this is a toolbar. Here you can have various tools for doing your analysis. Here you see a map canvas here where you can see your entire map and visualize the map spatial data here. On the left hand side you will see the browser window. You can browse various data here and whatever layers you are adding. As I said, in GIS we are using multiple layers for analysis. So it can be raster or a vector. Raster are basically the images. So it's an image. Yes. So someone has questioned in the chat that is the photo captured from the mobile is a raster. Yes, it's a raster data as it's a pixelated image. So yeah, so you can have various layers here. So right now what we'll be doing, we will be, so there are like there are various tutorials available online. Like I will give you just an overview, but if you want to study in more detail, you can go to those various open source tutorials available. So that's the advantage of this open source software. Like it has a various vast community and you can get various tutorials and learnings out there. Yeah. So now what we'll be doing, so I have collected your data. So whatever form you have filled, I have collected the location data from that form. So what now I am doing is I will be uh, I will be using that data to locate where you guys are from. Okay. So for that I'm creating a new layer. So for creating layer, I need to add your data. So your data I have collected in the CSV format in from the Google form. So I'm adding the data here. Okay, so this is the data that I have collected. Now I'm giving a coordinate system. So you need to give the correct coordinate system. So in coordinate system, there are various reference system, right? So as I mentioned, it could be conical, could be cylindrical. So every coordinate system has its number, specific number. So this is the geometry of that particular coordinate system, coordinate reference system, geometric coordinate reference system. So now I'm selecting the fields. Like I want to have the x. What is x? So what could be the x? The latitude or longitude? Can anyone answer? What is x? X is a longitude, right? So x values are longitude values. Okay. Okay, my screen sharing stopped. Share it again. Is my screen visible now?
Yes, I can see your screen.
Okay. Okay. We'll add the layers again. File, add layer, add delimited text layers. Okay. So x is a longitude. Sorry.
So how it will be longitude?
Yeah. So let's go to the slides. Here you can see in this slide, x is what the horizontal axis, right? So in longitude, so whatever the values are, it will be incrementing towards one of the axes, right? Towards the positive right here. So this is longitude. So these values are increasing clockwise, right? So that's why it's a longitude. Did you get? So
Okay, sir.
latitudes are see. So latitudes are going upwards. So it's a y-axis, right? y is a latitude. So I have collected all your data. Right now I'm using that data here. So just this data is for educational purpose, nothing else. So no need to worry about security issues. Okay, so I'm adding your data, and yeah, so this is all the data that is being collected. Now I'm adding OpenStreetMap. So OpenStreetMap to visualize where you guys are from. Okay, so yeah, we have these various locations. We have many people from Mumbai, yeah, IT Bombay, all my colleagues. We have people from Bangalore. We have few from Chennai. We have few from Coimbatore. So these are all the data that you have submitted. Like you clicked on that link. So I recorded your geolocation, your lat long, and I'm displaying it on the this map. So this OpenStreetMap is just a map. As I said, it is an open source map like Google Map. So I have overlaid your data over this OpenStreetMap. There are two layers here. So whatever layers you are seeing, there can be multiple layers in this GIS or QGIS software. So I have used just two layers. One is your data that is being overlaid on the OpenStreetMap. So we have also few from Coimbatore and few from Andhra Pradesh, Hyderabad. Yeah. So most of them are from north. Yeah, there are few from north. Most of them are from south. Yeah, few from Ghaziabad, Chandigarh. Yeah, yeah. We have spread all over India. Okay. Okay. Next, what we can do is we can publish this map on a web. We can publish this on a web browser. So there are, so in QGIS you have various plugins. So you can also create your own plugins. It supports Python scripting. So you can use Python scripting and you can create your own plugin. You can write a Python script to do all this analysis. Like let's say you want to create a web app and publish it on a browser. So there are certain plugins that someone has created to publish your data. So you can also create your own machine learning tool here. Like you can write a Python script machine learning tool and you can create that as a plugin which can be used further as a tool. So there are various tools available. You can also create your own plugins. So this is a toolbar layer above here, and there is also a quick search option here. So you can, so whatever analysis you do, let's say I want to do digitization. So digitization is a process in which you convert this raster data. So whatever data you have, like is a form of image, right? A satellite captures data in the form of image, and then this data need to be converted into vector data. So as I said, vector data has its advantage, right? So you can zoom to it any extent. You can also, another advantage is you can have attributes in the vector data. So you can store various data inside vector data. This is a point data, right? This is a vector point data. So I have stored all your geolocations and the address. So all this is possible in the vector data. In raster data you cannot do that. Like you just have the pixel values stored in that particular pixels. But in vector you can have various data stored on that particular point. So particular point layer on this, let's say this particular point, you can have various data stored, and all these point layers could have various data. So there are point, lines, and polygons. So that's the advantage of vector data. So we try to convert those raster images that we kept from the satellite using uh, digitization. So digitization is a process in which you convert raster to vector. So whatever analysis, like let's say you want to find the shortest path, you can't use satellite image as it is, right? You need to convert that into vector, and then you need to give particular location, let's say this location to this location, and find the shortest path that is lying between that path. So that is the application of vector data. So yeah, so we use raster data also for our various application. Let's say we want to classify a particular area, we can have raster data here, do analysis, do overlay analysis over that, and we can classify that data into classify the data as per our need. Yeah, so there are various plugins, as I said. So one plugin is, so you can add various plugins here. Your plugins option is there. You can manage and install plugins. So I have installed this OpenStreetMap, Google Maps. So all these are the plugins. So you can also enable the satellite image here. So the Google satellite image, satellite map has been enabled. So you can see the satellite data here. So this is a satellite image which you can visualize in QGIS. So I'm overlaying this. So right now this data that I imported, it's in the CSV format. CSV is the format that is being exported. That right now I'm converting it into a vector format. So for export, save feature as, and then exporting into vector. So in vector there are various format. One is the shape file. So shape file is the most common file that is being used for vector format, and then I give the name, let's say location, and georeferencing system is 4326. So note that whatever analysis you are doing, all these data should have the same reference system, so that these data are overlaid properly one above the other. So saving it. So now it has created a new file. So you can tick and untick to visualize it. So let's say I want to go to this layer. Just there is option zoom to layer. So go to that. So this is zoom to layer, and you are seeing it over the satellite image. So this is a campus. So these are my colleagues where they are from, like campus area. Yeah. And what other thing you can do is like quick thing, just publish this data, like whatever analysis you have done, you publish it to the browser. Like let's say create a web map. Okay. This is a plugin that is being created by someone. You can also create your own plugin. Okay, so it has been exported and you can see it on the browser. So these are the various location where are you guys are from, and you can also see the detailed data, like uh, your address, your geolocation. So you just added your lat long, and I have extracted all this detail from you. So this is how most of the apps and the browsers take data from you. So this is just for education purpose. I'm not using for any other purpose. Yeah. So this is all the data that you have given me. So here one person is there. I think it's Andhra Pradesh. Yeah. So yeah, it's Tamil Nadu. Sorry about that. Yeah. So that is all you can do using the spatial data. You can also add database to this QGIS. So as I said, the spatial data is very important for doing the analysis. So you can add uh, the database, the PostGIS database. So there is an extension to add this to your project. So you can add that data to your project, and you can do analysis using database. You can do various queries, right? So using database you can query which is the shortest distance between these two paths, what resides, like you can query anything, like where this which place is closer to this place. Let's say this is a person location, so which person is located near to this person. So all those querying is possible using database. But this data is spatial data, where you have the lat long and the spatial data features. So you can query various spatial data. You can find whatever analysis you want using this spatial data. So that you can do is using spatial database system. Yeah. So that was the quick overview of this, but I'm not going into much detail as this is a very vast software. Like there are various tools. Even I'm not aware of few tools. Like I need to Google few tools that I've not used. Like so there are various open source tutorials out there, and so this is a very vast. QGIS is a very vast software. So whatever application you need, just quick on a quickly do a Google search, just find out what settings you need to do, like what tools you need to use. Like I am aware of few tools like digitization, then georeferencing. Georeferencing is where you reference your image data over a particular reference system, let's say map or a other thing. Yeah, so that is the basic overview of QGIS. So using there is also web part of GIS, which is WebGIS, where you will be using JavaScript library uh, to do that. So there's a leaflet library, as I mentioned before. There's a leaflet library to do analysis on web. So you can create your own web app for that, and have do your various applications. So there could be various n number of applications. So whatever is related to the geographical location, that could be your application. So you can use leaflet library. So you can explore leaflet. So leaflet is a JavaScript library. So you can there's the tutorials available there. So you can just use the JavaScript functions APIs to create your own WebGIS. Yeah, uh, that was the quick overview of the QGIS and the GIS, introduction to GIS. Yeah, any other questions? Feel free to ask any questions. I know this is a new domain for all you guys. Like even it was new for me past year, but as I explored, I get to know it's has a vast applications. Any questions, guys, or you want to share anything? If there's no questions. Okay. If there is no question, then we can start with the quiz. Right, Ruchi?
Yes, sir. Before that, I would want to thank you for this wonderful session and thank you for the audience, YouTube audience and WebEx audience for attending the session. Hope it was helpful. Thank you, everyone.